Hi everyone. Today we will solve another problem of sectional solids. Here is the question. A cone of base diameter 60 mm standing upright is cut by a section plane such that the true shape is a parabola of maximum double ordinate 50 mm and vertex of the parabola is 70 mm from this ordinate. Draw the front and top views and true shape of the section. What is the inclination of the section? So this question is something different from the problems which you already solved. You can see a cone, the base diameter is given 60 mm, standing upright. Standing upright means it is resting on its base on HP on the ground. So definitely you can see in the top view a circle and in the front view a triangle. So you can draw the circle of diameter 60 mm. It is cut by a plane such that the true shape of the parabola is a maximum double ordinate 50 mm and vertex of parabola is 70 mm. That is, here anywhere in the question the height of the parabola is height of the cone is not mentioned. It is unknown. Instead of that, they have given the details of the true shape. They have given the true shape is nothing but a parabola, and the height of the parabola, that means vertex of the parabola, is 70 mm. That is nothing but its height, and double ordinate 50 mm. So before moving to or before solving the before going to the solution of the problem, I will give you just an idea about the parabola. So this is basically the shape of a parabola. They have given, you can see the height, it is AB, which is given in the question. AB equal to 70 mm, and CD, this is what is the double ordinate, and CD is equal to 50 mm. I think it's clear. Now we will move to the solution. So I already mentioned in the top view you can see a circle. So you draw a circle of diameter 60 mm and name the figure A, B, C, D, etc. to H. But the front view is, front view is a triangle, but without knowing the height, we cannot draw the triangle. So I just drawn the axis only, in which the height is unknown. Now it is given in the question, the length of the ordinate, double ordinate, is 50 mm. So in order to get that 50 mm, what you have to do is, before completing the orthographic view of the cone, we are taking, or we are going to some part of the section also. So that means I am taking a distance of 50 mm in the top view. That means you can see I marked as a diameter 50, just 2.5 up, 2.5 down. You slide your scale up to which the total distance is 50, and you draw a line as shown in the figure. And you mark that point as 1, project it upwards, you will get the point 1 dash. Now it is given in the question that the height of the parabola is 70 mm. So what you have to do is, fixing the point 1 dash, you draw an arc of length of radius 70 mm with 1 dash as the center, similarly E dash as the center. I will repeat the step. Once you get the point 1 dash with 1 dash as the center, you draw an arc of radius 70 mm. So you will get one arc. Similarly, you draw another arc of 70 mm with E dash as the center. So these two arcs will meet at a point which is shown in the figure. Now you draw a line from the point 1 dash to the meeting point of the arc as shown. Once you get that point, you can complete the front view of the triangle as shown in the figure. You join E dash, definitely the apex point is O dash, E dash O dash, and A dash O dash. So now you get the complete orthographic view of the triangle and also a line which is connecting the point 1 dash and the meeting point of the arc. Now you pass the section plane as shown in figure. You pass the section plane through the point 1 dash and meeting point of the arc as shown in figure. Now name the points. Already you have given the name 1 in between B and C, that is 1 dash. Similarly you give for 2 dash, 3 dash, 4 dash, come in the reverse order, 5 dash, 6 dash, 7 dash. So total you have 7 cutting points, 1 dash, 2 dash, etc. up to 7 dash. Step 8. Definitely you know that you project it downwards. So you project 1 dash, already you got the point 1 between B and C. You project 2 dash in order to get the point 2, but you can see it won't meet at any point. So similarly for 6 dash also, when you extend 2 dash and 6 dash downwards, you won't get the point 2 and 6 because it won't meet at any point. So what you have to do is you project it project from 2 dash and 6 dash to the true length. True length is nothing but O dash E dash because OE is parallel to the XY line in the top view. So O dash E dash is the true length. So when you project 2 dash and 6 dash, you get 2 double dash and 6 double dash. Project it downwards. When you project it downwards up to the line OE. So when you project it downwards, you get the corresponding points. Measure that particular distance and mark that distance along OC and OG to get point 2 and 6. I will repeat again. When you project a line from 2 dash and 6 dash to the true line in order to get 2 double dash and 6 double dash, project it downwards till it meets OE. Once you get the point along OE, measure that particular distance from O, that is from the center, and mark that distance along OC and OG to get the point 2 and 6 respectively. Now you project 3 dash, project 4 dash, 5 dash, 7 dash. So you will get all the points 1, 2, 3, 4, 5, 6 and 7. So I mark the cutting points here in order to make it very easy. You can refer it in order the cutting points. Now join 1, 2, 3, 4, 5, 6, 7. So this will be the shape what you are getting in the sectional view. Definitely you can see it is a parabola of a small parabola. Now in the next step, in order to get the true shape of the section, what we do, we will consider another section plane or another line parallel to the section plane x1, y1, and project perpendiculars from all the cutting points 1 to 7 as shown in figure. Now mark the distance correspondingly along the corresponding projection lines. 1, you measure the distance from the point 1 to xy and mark it correspondingly along the projection line of 1 from x1, y1. Similarly 2, 3, 4, 5, 6, 7. And once you join, you will get a figure as shown. And this is the final solution of the problem. So definitely when you measure, you will get the double ordinate of the parabola is 50 mm and height from the vertex is 70 mm. If you are not getting these values, your solution is having some problems, recheck it and redraw it. And in the question, we are also asked to measure the angle of inclination of the section plane theta. I marked it theta here. You can just measure also the height of the cone, which is unknown. So this is the final solution. And remembering one thing, this is a problem which is entirely different from some previous problems, because in all the previous problems they have given the exact dimension of the figure, so that it is very easy to draw the orthographic view. So here it is not like that. So please go through it. Thank you.